we're going to do more types of examples with completing the square, and then we'll use completing the square to actually solve a quadratic equation, which was our point to begin with. Just to make it really obvious, let's go back to what we learned probably a year ago, expanding double brackets. In the case where the double brackets they're all both the same, it's something squared. X plus 5 squared is actually x plus 5 times x plus 5, right? This is what I mean by double brackets. And when we expand it, we do this times that, which is x squared. Then we're doing 5 times x plus the outside terms 5x. The last terms 5 times 5 is 25. So and then we can always combine these two and say this is x squared plus 10x plus 25. So when we look at this term, 10x, that's double this 5, right? This term is the square of this 5, right? So this 10x, the 10 is 2 times the 5. This 25 is the 5 squared. Let's do this one. X minus 7 times x minus 7. When we expand it, it's x squared minus 7x minus 7x. So I'm just going to do it in one go now. 14x. Minus 7 times minus 7 is a plus 49. And as you can see, again, this negative 14 that's in front of the x, that's twice our negative 7. Negative 7 times 2 is negative 14. This term, 49, is the square of negative 7. 7 times 7 is 49. Negative 7, the negative times negative is a positive, so there we go. Just like here, right? The square, and here 2 times. And in our formula yesterday, this number was called b, remember? Okay, here, same thing, x plus 3 times x plus 3 equals x squared, first times the first, the inside ones plus the outside ones is plus 6x, and 3 times 3 is 9. And again, this plus 6 is double our b value, we called b yesterday, and this 9 is our b value squared. So what we did in the last class is we went backwards. So we asked ourselves, where did this 20x come from? If it was a term that was squared, right? And what we did was we said, well, we will half this, and that's where it must have come from. So x plus 10, half of plus 20 is 10, plus 10, and we'll square that. And then because we know that this 10 also gets squared, so plus 100, and that's not in here. There's no plus 100. So we have to subtract that 100, right? And then if we want to check our answer, we can expand this and say x plus 10 times x plus 10 minus 100. That should be this then. Let's see. When we factorize it, x times x is x squared plus inside 10x, outside plus 10x, the last terms plus 100, and then minus 100. X squared, 10x plus 10x is 20x, plus 100 minus 100 is nothing. So this is what we get, and that's what we started with. So this must be correct. Okay, that was a quick recap. What if we have a constant term as well in our quadratic expression? Really not a big deal, because we ignore it to begin with and then we add it in later. So if this was our entire expression, we would say, well, if we complete the square here, we take half of plus 12, which is 6. Say we square it. To make up for this plus 36 that we're going to get, we subtract 36. We subtract the square of this term. Subtract 36. Okay, that was only this part of the equation. We have a -3. We just add that on. And now it's balanced out. Now it's the same again. And of course we can combine like terms and say, well then this is x plus 6 squared minus 36 minus 3 is just minus 39. So that's how you handle that. You just ignore this at first, take this part, complete the square, and combine your constant term with your other constant term that you've used, that you've put in to complete the square. Okay, now it's an actual quadratic equation. How would we solve this? We will move the 3 out of the way, so we only have this, because that's easy to deal with, right? X squared plus 4x, so we add 3 to both sides. Now the 3 is over there. We deal with this like we learned before. Half of 4 is plus 2. And we have to subtract this term squared. So we subtract 2 squared, right? That takes care of this, and it equals 3. Let's leave this in there, and 2 squared is 4. Let me write that. We move the 4 over to that side, because we want x as much as we can all by itself, right? So plus 4, so 7. Now we square root both sides, which gives us x plus 2 equals the square root of 7. So x equals, we subtract 2 from both sides, -2 plus or minus the square root of 7, because the square root of 7 could be a positive number or a negative number, right? And if we'd have to use our calculators to find the square root of 7, but it would give us x equals -2 plus or minus that. It would give us 0.65, or x equals a -4. We've rounded that. These are 4 away from each other. That makes sense, doesn't it? Yes, it does. Okay. So here, you just put the numbers over to one side and complete the square on the left side, and then solve for x. I need to pick up my kids. What if the coefficient of your quadratic equation is not 1? Say it's 3. The coefficient of your x squared term is not 1, right? Because up to now they have been, and it's been fairly easy. What if it's like 3? We need to do something about that before we can complete the square. if I want to get rid of the 3 here, I just divide by 3, right? So how about we just divide both sides of the equation by 3. Here that means dividing each term by 3. It gives us x squared minus 3x plus 2 equals 0 divided by 3, still 0, right? And then I solve it. So I move the constant term over to the other side by subtracting it. I complete this square. Half of negative 3 is negative 1.5, right? I'm right. Okay. Now I have to subtract the square of 1.5, which is, oh my goodness, 1.5 times 1.5. Yeah, we all know that. That's 225. So minus 2.25. I love how I have a fraction and decimal in there. That's not very smart. Oh well. Now we move the constants over to the right side, right? So I just changed it to a decimal. Here I add 2.25 to both sides, which gives me 0.25 on this side. I take the square root of both sides. That, and the square root of 0.25, I'm not going to work that out now. Also not going to take my calculator. To get x by itself, I add 1.5 to both sides. So 1.5 plus or minus the square root of 0.25. That's going to give me 2 answers. I will have a positive square root of 0.25 added, or a negative square root of 0.25 added. It gives us 2 different numbers. Yeah, so these are some examples, and now you'll be able to use it to solve an actual quadratic equation.